Here we have some more examples of quadratic equations. In problem number 15, notice that we have an x and it's being squared. So to get the x by itself, what we'd want to do is undo the square by using its inverse property, which means that we want to take the square root. Now let's look at what happens in this case. Here we take the square root of both sides. The square and the square root undo each other and leave you with x. When we take the square root of both sides, we introduce a positive and negative solution. However, the next thing that we worry about here is notice that we end up with having to take the square root of negative 25. Now, let's think about this for a little bit. What number can you multiply by itself to get negative 25? If you do 5 times 5, we get positive 25. If we do negative 5 times negative 5, we also get positive 25. So when we come here and we try to take the square root of negative 25, there isn't a normal number that can work. In fact, let's pull up our calculator here for just a second and see what happens when you try to ask your calculator to take the square root of negative 25. Here, I do my square root of 25. Oh, just kidding. Let's do negative 25. And when I hit that, notice error, non-real answer. And so we do really actually have kind of a legitimate problem here when we go to try to take the square root of a negative number. And if all you're looking for is a real solution, you would say that there are no real solutions to this problem because you can't take the square root of a negative number. That said, it's really close to 5. And so at this point, what I want to introduce to you a little bit here is the concept of an imaginary number. And we call them imaginary because they're not real solutions. But imaginary numbers boil down to the fact, or an imaginary number, we use the letter I to represent that. What we'd like to do is we like to think of the square root of negative 1 as I. So here, if I want to come up with this, notice that kind of like we could pull perfect squares out, we can pull out this square root of negative 1 from my problem. And anytime that you see the square root of negative 1, we can write I instead. That says I have an imaginary solution coming up, but, and then we can do times by the square root of 25, which is just 5. So x can either be a positive I times 5, and a lot of times you'll see that written like this, or a negative I times 5, and you would see that written like this, negative 5i. So if you're being asked to give solutions, we could record our answer to this quadratic equation as x could be 5i or x could be negative 5i. And again, the I just means that there's a square root of negative number involved with that. And the I technically actually represents the value of the square root of negative 1. Now, when do you, if you're trying to solve a quadratic equation for time or for a distance, having a not real solution doesn't make a lot of sense. However, there are some really great applications out there in electronics and other things where imaginary numbers actually are an important part of the solution process. So that's why I'd like to introduce them to you here at this point in the class, is that if you ever get in this situation where you're taking the square root of a negative number, I want you to know you're going into the imaginary realm, and go ahead and break it up and get used to writing the notation in this way. You'll get into complex numbers and things like that a little bit more in pre-calculus, and then more if you are going into a field where there are applications involving those types of functions. With that in mind, let's try a problem here like number 16. We want to get the y by itself. It's being squared, so we're going to take the square root of both sides. On the left, the square and the square root undo each other and leave me just with y. On the right, I introduce the square root, so I have two possible answers of the square root of negative 100. I don't like the negative in there, so think of that as the square root of negative 1 times the square root of 100. The square root of negative 1 is just I, and the square root of 100 is plain old 10. So I can think of this as two solutions, positive I times 10, so we get y equals 10i, and negative I times 10, so negative 10i. These would be our imaginary solutions, and there are no real solutions for this particular value when I go into it. Now, these can come up even in more complex equations. Notice here I want to get the y by itself. There's a 5 in the way and a squared in the way. The 5 is trapped inside the squared, so I have to get rid of the squared first when I'm peeling things away to get the variable alone. So here I take the square root of both sides. On the left, the square root and the square undo each other and leave me just with y minus 5. On the right, I introduce the square root, so I have two possible solutions of the square root of 98. In this particular case, I see that negative number inside, so I'm going to pull that out as a -1 so I can get some imaginary values. And I have the square root of 98 that I need to deal with. Double check and make sure that your square roots have, if they have any perfect squares in them. If you break 98 down, you'll find that it's 2 times 49, so we have a pair of 7s in there. So we do still want to simplify square roots when possible. You may do some of these things in more than one step. I just don't want to lose anybody. So I had that square root of -1, which was I. I have the square root of 49, which is 7. And then I still have the square root of 2, which I'm not able to simplify any farther. Normally, you'll see this written as 7i times the square root of 2. Oop, don't lose the equals there. So y minus 5 is equal to 7, plus or minus 7i radical 2. Now, to finish getting the y by itself, I have to add 5 to each side. And that will get the y alone. Let's go ahead and give ourselves a little bit more room here. Y is equal to plus or minus 7i square root of 2 plus 5. Because this has a square root and an I can't actually add those together. And writing your answer like this, you'll have two different solutions is totally fine. If you like actually writing them out, if that makes it easier for you to understand your solution. Many times we'll see the number portion first and then the imaginary portion second is kind of the more common way that you see things written. So here, the positive 7i radical 2 plus 5 we can write as 5 plus 7i radical 2. And then for the negative solution, we write the number part first, which is 5, and then we're going to choose the minus part, 7i radical 2. So these would be the two solutions that we could get from this larger equation. So when you take the radical, if there's a negative number, think of that, pull that -1 out, the square root of -1 out, and think of it as I. And then you'll want to simplify any other parts of that radical just like you normally would in an equation. And so this kind of puts all of those things that we've talked about so far together in one problem.